Welcome to example number 1. We have a waterbed with the following dimensions. 2 meters, let's say that's the width, 2 meters in length, and then we have a depth of 30 centimeters, so that's 0.3 meters. And we're asked to find out what is the weight of the waterbed, and B, what is the pressure that it exerts on the floor. We'll assume the entire lower surface of the bed makes contact with the floor. So we're not given everything. You do have to look up one piece of information. We're assuming this is filled up with fresh water, and the density of water is 1,000 kilograms per meter cube. Now, if we know the density, and then we know the dimensions of the bed, one hopefully could realize that you can calculate the mass. Let's calculate the volume of the bed. The volume of the bed would be length times width times height. So that's 2 meters multiplied by 2 meters multiplied by 0.3 meters, which gives you a volume of 1.2 meters cubed of water. Now, density is mass over volume. So we can calculate the mass of the water in that bed. The mass is equal to the density times volume. So that's 1,000 kilograms per meter cubed multiplied by 1.2 meters cubed. You can see the meter cubes will cancel out, and you'll get a mass of 1.2 times 10 to the power 3 kilograms. Now that you know the mass, you can calculate the weight that this bed has. The weight is calculated by taking the mass and multiplying by the acceleration due to gravity, g. So that's 1.2 times 10 to the power 3 kilograms times 9.8 meters per second squared. And that gives you around 1.18 times 10 to the power 4 newtons. That's about, in pounds, around 2,600 pounds. Now, a regular bed only probably has a maximum weight of about 300 pounds. So it's quite heavy. Really, the placement of this bed is important. You would want to place it on a very supportive floor or the basement, for example. Okay, so that was part A. Let's move on to part B. Part B is asking you to calculate the pressure that is exerted by the water on the floor. And we're assuming that the bed is in its normal position so that the entire lower surface of this bed is in contact with the floor. So, if you want to calculate the pressure, pressure is force over area. You just calculated the force. The force is 1.18 times 10 to the power 4 newtons. You just have to divide by the cross-sectional area of the floor. That's this area in here. So that's 2 meters by 2 meters, which is really 4 meters squared. So if you multiply that out, or actually divide that out, you're going to get really around 2,940 newtons per meter squared, or 2,940 pascals. So I've got a little bit of error here. I wrote 2.95, or it should be 2.94. So you'll notice that's relatively high pressure, but actually a normal bed would actually have more pressure. Why do you think a normal bed would have more pressure? Hopefully you realize that in a normal, ordinary bed, it's going to be supported by 4 legs. And those legs have a small cross-sectional area. So although a 300-pound bed might have a lot less weight, but it's actually being only supported over 4 legs, which is a much smaller area, and you'll find that you'll actually get probably around 100 times more pressure from those 4 little legs than you will get over the waterbed. However, the waterbed has a lot more weight, and you really got to think carefully about how much support you have to provide underneath for all that weight. Okay, and that's it for example number 1.